Let's talk a little bit more about geometric mean, specifically how all of your geometric mean problems start to follow a pattern as you do more and more of them. You'll notice these three examples, the purple, yellow, and pink triangles. As you work through geometric mean problems, you'll find that all of them follow one of these three patterns. When you're setting up your ratios, your altitude, if you're given the altitude, is always the one that's doubled. So we notice right here, x is our altitude, and x appears twice in our ratios, eventually to be multiplied by itself. Over here, 24 is our altitude, so 24 appears twice. Now over here, we don't have an altitude, we have a leg, and so our leg appears twice. Now, we also notice that when it comes to knowing an altitude, the two pieces of your hypotenuse are copied down. Well, they're not copied down in that order, I apologize. I kind of did a little switcheroo, but it doesn't really matter because they're going to multiply against each other when you do your cross multiplication. So if I had put them in that order, it wouldn't have made a difference. Same thing happening here, pieces of your hypotenuse being copied down to eventually being multiplied against each other. Now here is where, when you're given a leg, something is different. The section of the leg that is coming in contact with the section of a hypotenuse coming in contact with the leg given, that's the one that you carry down. But you'll notice that I don't have the 27 carried down. The other piece that I have is the entire hypotenuse. So I took 9 plus 27 to make 36, and that is carried down into our ratio. So the altitudes in the legs always double, but if you're dealing with a leg, you also have to add up your whole hypotenuse. Let's work a couple examples. Okay, in this case, we're given an altitude. So we know the altitude doubles, and the altitude is going to be put across from itself for cross multiplication purposes. And then we'll just copy the other two pieces. So 72 times 2 is 144. X times x is x squared. Take the square root of each side, and x is equal to 12. Same thing here, we're given an altitude. In this case, our altitude is 4. So the 4 is what's doubled. And we'll write down our other two pieces. 4 times 4 gives me 16. 8 times x gives me 8x. So I need to divide by 8 on both sides. And x is equal to 2. Now, if we look at this one, are we given an altitude? No, we're given a leg. Remember, the leg is still the thing that doubles. So I've got x here and x here. And then I'm going to look at the piece of the hypotenuse that's close to the leg. That's 32. And then the whole hypotenuse, well, that's 18 plus 32, which equals 50. So I'll have x times x gives me x squared. And 32 times 50, which gives us 1,600. Then we'll take the square root on each side. And x is going to be equal to 40. Look at this one. Again, we have a leg. So our leg is what's going to double. And then we have the part of our triangle close to the leg. And then we have our entire hypotenuse. I don't know what 32 plus x is, so I'm just going to have to put 32 plus x. Now when it comes to your cross multiplication, be very careful when you're doing 32 times some kind of quantity. You want to make sure you're using the distributive property. So 32 times 32 is 1024. 32 times x is 32x, and then we'll have 40 times 40, which we learned from our last problem was 1600. Let's go ahead and minus the 1024 from each side. We'll have 32x equals 576. Divide by 32. And you'll get 18 for x. All right. And those are the shortcuts to solve for x using geometric mean ratios.